Well, it's Friday and we're going to finish up our lessons on light today. We have learned so much about light. Yesterday we looked at how light can be absorbed or reflected or blocked. We looked at three words at first. We looked at objects that were opaque. That's objects that block light altogether. No light goes through. Objects that are transparent, like your windows, like your glasses, like glass that you look through anywhere, things that let light through, and things that are transparent that let some light through but block some of the light. We looked at those. We looked at what a mirror does. A mirror reflects light. Reflection of light is bouncing off of light. We looked at what water does. If you're looking at a straw, part of it's in the water and part of it's not. It refracts, it bends the light. And then that diffraction, just bending light around an object to make it blur. It makes it a little blurry, the blurry shadow you see sometimes around the shadow of an object. So we learned lots of words yesterday. We've learned that light is on the electromagnetic spectrum this week. We've learned light travels in transverse waves. Boy, we have learned so much about light this week. It's a lot to remember, isn't it? So we're going to finish up today with a digital lesson covering what we talked about yesterday, just as a review. And then after this digital lesson, you'll have a vocabulary assignment using those 6 words that I just talked about, okay? So I think you'll do well on it. Just pay attention to the digital lesson today, and I think you'll enjoy it. Here we go. Maybe so, maybe not.
We're having a dance at school this week. We rented this cool disco ball. When we shine different colored lights on the ball, they're reflected all over the gym floor. Click the hot spots to see this in more detail. Then when you're ready to explore the properties of light further, click the next arrow.
All right, let's find out.
Light is everywhere on our disco ball. Since the chain is made of shiny metal, the light reflects and bounces off the chain too. The mirror does not absorb light. The mirror reflects light straight back. The light will be reflected back at the same angle as it hit the mirror. This makes really cool beams of light as the ball spins around. Light does different things when it hits different surfaces. These tiny mirrors will reflect all the light that hits them, causing lots of beams of light to shine on our dance floor. Welcome to the lesson, What are some properties of light? In this lesson, you'll learn about the properties of light. You'll also find out how light is bent and reflected. The vocabulary words for this lesson are reflection, refraction, opaque, transparent, and translucent. Click each word to learn more about it.
And we've already talked about those, so we're going to move right ahead. I think my computer's a little slow today.
Did you know that light travels? In fact, there's nothing that travels faster than the speed of light. Light really moves. It takes only about 8 minutes for light from the sun to reach Earth, a distance of around 150 million kilometers. Light travels at approximately 300 million meters per second, or 1 billion kilometers per hour.
Light travels really fast.
Different materials have different properties in relation to light. Some materials allow most light to pass through them, and some materials let only a small amount of light pass through them. Some materials do not allow any light to pass through them. Click the images to learn more about how a material's properties affect light. Windows allow light to stream into your house, keeping your house warm and bright. Clear windows made of glass are transparent. Transparent means the material allows almost all light to pass through it. Light passes through a transparent material without its rays being scattered. The thin cloth of a tent allows some light to pass through it. This is a translucent material. The thin cloth scatters the rays of light coming through it, so you are not able to see clearly what's on the other side of the cloth. Have you ever wanted to sleep in on a Saturday morning, but light was coming in through your window? What could you do? Well, you could pull down an opaque blackout shade. Opaque material does not let any light through it.
All righty, moving on. Maybe. Oh, computer's working pretty slow today. I don't know if it's going to go on or not.
Transparent, translucent. You see transparent, translucent, and
Okay, I think we got it going now.
you see transparent, translucent, and opaque objects every day. Click the highlighted areas to discover more about these kinds of objects. A spoon, a desk, and a wall are all opaque. Opaque objects will cast a shadow. This table is opaque, which means light cannot pass through it. Most objects we encounter are opaque. Opaque objects block light. Colored liquid, a curtain, or frosted glass is translucent. Translucent objects scatter light waves. These safety goggles are transparent. Transparent objects are clear. Items that are transparent allow most light to pass through them. This window is transparent. It allows light to pass through it without the light being scattered. This measuring cup is translucent. It allows some light to pass through it, but details can be seen through the cup. The light is scattered. Look at these objects. They can be classified by how they interact with light waves. Drag each image to the correct box to indicate whether the object is transparent, translucent, or opaque.
All right, so transparent, remember that means you can see through it just fine. It lets light come through. I believe these are windows you can see through, or glass doors. All right. A clear glass or a clear bottle, that looks transparent to me. Okay, I don't see anything else really transparent, I don't think. I can't tell what this is. We'll come back to it. Aluminum foil, you cannot see through aluminum foil. Light bounces off of it, but you can't see through it, so it's opaque. A blanket, you can see a little light coming through that blanket that he has, or maybe tent. So I think that's translucent. This looks like a piece of wood. You can't see through it. It's opaque. Umbrellas, you can't see through an umbrella. They're opaque. Or maybe not. I guess you can see a little light if they're really thin material. Like these look like maybe those little Chinese or Japanese umbrellas. I guess they're a little thinner than the kind you or I would use. So I guess they're translucent. Oh, it said they're made of paper umbrellas. That's the difference there. Okay. A rock. You can't see through a rock. And this looks like maybe frosted glass or something. A frosted window. Yeah. So
Great job. You sorted the objects by the way they interact with light. Translucent objects let light through but scatter the light. Transparent objects let light through them without scattering. Opaque objects don't let light pass through them. Now let's learn more about other properties of light.
all right, on to reflect and refract. Eventually.
Have you ever wondered why you see your image in a mirror? You see your image because of a property of light called reflection. Reflection is light bouncing back when light rays hit an object. Click the dots on the timeline to learn more about reflection as a property of light. Why are you able to see the mountain reflected in the nearby calm lake?
Well, because it's smooth surface and the light waves are bouncing back off of it.
Rays of sunlight hit the mountain and are reflected off the mountain.
Okay.
The light that is reflected off the mountain hits the water in the lake. The light from the mountain is reflected off the calm lake's surface, allowing us to see the mountain's reflection in the water.
All right. So reflection is all about the light bouncing off of a smooth surface so that it comes back to our eyes and we can see it in the reflection.
Did you know that we can see color because of light? Click the pictures to learn how light allows us to see color. Colors surround us. We can see color because of light. This boy is seeing the colors of the globe. The light that comes from the sun or from normal light bulbs looks white. However, this white light is a mixture of all the colors of the rainbow. The light moves from the light source and hits the globe. When light hits an object, the object absorbs all the colors except for the color we see. In this example, the globe absorbs all the colors of light except for the colors on the globe. Blue light is reflected off the globe's oceans. The globe reflects the blue light toward our eyes. Our eyes receive the reflected light, and our brain interprets what we see as a color. We learned that light can be reflected or bounced off objects. But did you know that light can also bend? It's true. Refraction is light waves bending as they pass from one material into another. Click the images to learn more about refraction. Have you ever looked at a straw or a spoon in a glass of water? The straw or spoon will look broken in the water. As light enters the water from the air at an angle, its speed changes, bending the light ray. So the straw looks bent in the water. Here's another example of refraction. This oar is actually straight. Although the oar is straight, it looks bent because the light slows down and bends as it enters the water. White light is made up of all the colors of the rainbow. Each color has a different wavelength, and each color bends a slightly different amount. When light enters and leaves a prism, it bends, separating the light into the different colors of the rainbow. Refraction also creates the rainbows we see in the sky. As sunlight passes in and out of falling raindrops, it is bent, separating the white light into different colors and making a rainbow. Some of these pictures show light rays being reflected, and some show light being refracted. Think about what is happening to the light rays in each picture. Drag each image to the correct box.
Okay, so we learned that a rainbow is caused by refraction, right? The light wave enters the airdrop, the water droplets in the air, and bounces back. And as it bounces, it's bent into its different colors. Like a prism bends the white light into its different colors. So a rainbow is an example of refraction. This little boy is looking at himself in a smooth surface. That's light bouncing back. That's reflection. Here we can see a mountain's reflection. Because this is a smooth surface, the light is bouncing off of this into this and bouncing off that into our eyes. Reflection. Here, a straw looks bent in a glass of water. Refraction is when it looks like the bending of light. Here, a spoon or a fork looks like it's bent. That's refraction. And here, a little boy is standing in the mirror. Is that Alex Green? I think it is. Fixing his hair. Just kidding, Alex. So that's a reflection, like a mirror.
Great work! You sorted the images into the correct boxes. When light is reflected, it bounces off an object. When light is refracted, it bends. Many useful devices, including eyeglasses, telescopes, and hand lenses, use lenses to help focus light. Have you ever wondered how they work? Lenses refract light. Click the images to learn more about how different kinds of lenses affect light. Some people wear glasses. Glasses use different types of lenses to help people see. This lens is concave, which means it is curved inward. When light goes through a concave lens, the light diverges or spreads out. If a person is nearsighted, faraway objects look blurry. When a nearsighted person puts on glasses, the concave lens spreads apart the light before it enters their eyes. This makes the rays focus on the correct parts inside the eyes. When you look at objects in the night sky through a telescope, it makes things in the night sky look bigger and closer. The moon looks bigger through a telescope than it does with just your eyes. When you look through a hand lens, what do you see? Objects look bigger so you can observe more details. The telescope and magnifying glass both have convex lenses. A convex lens curves outward from the center. When light goes through a convex lens, the lens bends the light so the light rays come together or converge to bring an image into focus. Convex lenses make objects look larger. Is this statement true or false? A concave lens causes light rays to converge or move together.
Concave lens. So the concave lens is bent inward. So that means the light is coming in and it's spreading it out. So it is not causing them to converge or move together. It's spreading them apart. So this would be a false statement.
That's right. The statement is false. A concave lens curves inward and causes light rays to diverge or spread apart. A convex lens curves outward and causes light rays to move closer together or converge. You've learned about a lot of ways that objects can interact with light. Drag each label to the picture it describes.
All right. An opaque object, an object you can't see through. Well, you can't see through Legos, can you? A prism, light shines through it and separates it into a rainbow. Look right here, the light's coming in this side, and then it's bent and turned into those colors. I think that's a prism right there. Transparent object, you can see through it. Well, that looks like a glass fish or something. I guess that's it. Yep. Translucent, you can see through it just a little bit. I think that's it. All right, this is an inward curve. An inward curve is a concave, like you're going into a cave. Concave lens. And that curve outward is a convex lens.
That's right. Great work. You matched all the items. A prism separates white light into all the rainbow colors. A concave lens makes light rays diverge. A convex lens makes light rays converge. Translucent objects scatter light. Transparent objects allow light to pass through them. Opaque objects block all light. You've learned a lot about light, reflection, and refraction. Let's take a quick look at the main points you covered. Objects have certain properties in relation to light. A transparent object allows most of the light through it. A translucent object allows some light through it, scattering much of the light. An opaque object does not allow light to pass through it. Light can reflect or bounce off objects. We see objects because they reflect light. Objects absorb all colors of the spectrum, except for the color of the object. We see an object as a certain color because that color of light is reflected from its surface. Refraction is the bending of light when light rays enter a different material at an angle and change speed. Refraction may cause objects in water to look bent. When light passes in and out of a prism or raindrop, light is refracted and is separated into the colors of the rainbow. Lenses can affect images by bending light rays. A concave lens makes light rays diverge, and a convex lens makes light rays converge. Concave lenses help nearsighted people to focus on distant objects. Convex lenses make objects look bigger and closer. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
All right. Well, thanks for being a good listener this week. We've learned so much about light and its properties. I want you to go and do your assignment for today, some words that we've heard 2 days in a row now, and that you also did in your book yesterday. So you should have no problem doing the vocabulary assignment for this lesson today. I hope you can get it done and make it 100, and I hope you have an awesome weekend.